Good afternoon, my dear friends. It's nice to be here, and today we will start to study and to learn muscular systems. First, I'd like to know if you can hear me clearly. Please also don't forget to put your name in the chat box in order I can know who of you are absent or who are present today. Okay. Thank you. So a couple of words about the last lecture and last home test. Recently I put the correct answer, and you can check yourself and now what is the right or not correct answers. Mostly I found a lot of mistakes, especially when you analyzed the picture of pelvis. So I hope I will tell your teachers to detail and to make more effective study about this topic. Okay, so let's get started. And this is a picture of one very famous plastinated body. Whole body plastinated specimens from Gunther von Hagens. I saw this body personally in the Hagens Museum in Germany. I put this picture because to illustrate the moving. As you know, our life is movement. It's hard to imagine what life would be like without muscle tissue. We could not sit, we could not stand, we could not walk, speak, or grab some object. Without muscle tissue, the blood did not circulate in the body because there would be no heart to move it through our vessels. Also, our lungs could not rhythmically fill with air, and even in the digestive tract there would be no movement along any of our internal organs. So we devoted this lecture to myology, and we will be talking about muscular system and muscular object, muscles in our body. What is the myology? Maybe you know. It is the scientific study of muscles and muscular tissue, as well as about this is a study about diseases, muscles development, etc. There are three types of muscular tissue in our body. You see, it is skeletal, skeletal muscles tissue, it is up, and cardiac muscle tissue and smooth muscle tissue. What is a skeletal muscle tissue? It is so named because the function of most skeletal muscles is to move the bones. And skeletal muscle tissue is referred to as striated because alternating light and dark protein bands, or we called it striations, and those striations or protein bands are visible when the tissue is examined under a microscope. Skeletal muscle tissue works primarily in a voluntary manner. We use our brain, we use our high part of our brain to move our skeletal muscles. Second group or second muscular tissue is cardiac muscle tissue. It is found only in our heart, where it forms most of the heart wall. Like skeletal muscle, cardiac muscle is striated, but its action is involuntary. Its alternating contraction and relaxation cannot be consciously controlled. No consciously controlled for working cardiac muscle tissue. The third group is smooth muscle tissue. It is located in the wall of hollow internal structures such as the blood vessels, airways, and most organs in the abdominopelvic cavity. This type of muscle tissue is also attached to hair follicles in the skin, and smooth muscle tissue gets its name from the fact that under a microscope, by examination with microscope, it appears non-striated, or it is just smooth non-striated tissue. And as well as cardiac muscle tissue, the action of smooth muscle is usually involuntary, no consciously control. What is the function? What is the function of muscle tissue? There are four main functions. First one is producing body movements. Total body movements such as walking and running, and localized movements such as grasping and a pencil or something, or a ball, keyboarding or raising your hand, really rely on the integrated function of skeletal muscles, bones and joints. Second one, stabilizing body position. Skeletal muscle contractions stabilize joints and help maintain body position. such as standing or sitting. We mean every poses without movements. Postural muscles contract continuously when you are awake. For example, sustained contraction in neck muscles hold your head upright when you are listening me, for example. And every time when we don't move our parts, our body parts, some of the muscles are contracted. Third function is storing and moving substances within the body. Sustained contraction or ring-like bands of smooth muscles called sphincters may prevent outflow of the contents of a hollow organ. Temporary storage of food in our stomach or urine in the urinary bladder is possible because smooth muscle sphincters close off the outlets of those organs. Cardiac muscles contractions pump blood through the body's blood vessels. Contraction and relaxation of smooth muscles in the walls of blood vessels help adjust their diameters and thus regulate the rate of blood flow. Smooth muscle contractions also move food and substances such as bile and enzymes through the gastrointestinal tract, push gametes such as sperm and oocytes through the reproductive system, and propel urine through the urinary system. Skeletal muscles contraction indirectly promote the flow of lymph throughout the body and aid the return of blood in veins to the heart. And fourth function, it is not that is some additional function, but that's it. Producing heat. As muscular tissue contracts, it also produces heat and warmth, a process called thermogenesis. And when we move, we feel warmer, and if you are cold, especially here in St. Petersburg, because there is a lot of snow outside, and the temperature is -1, and sometimes we move intensively, and it helps to produce more energy, more heat, and more warmth. I hope all of function of muscular tissue understand of you, and it will be no problem. Next, it is a very good expression belongs to the great Russian physiologist Ivan Sechenov, and this is a very famous expression about muscles activity. Look at the picture, and read that as every movements, if we mean child laugh or smile, Garibaldi's smile, when he is leading to the execution, or when the girl laugh or tremble or sometimes cried when she is thinking about her laugh, even when great Newton creates and writes the laws of the world. Everywhere, as Sechenov said, everywhere the last fact is muscle movement. Very, very good expression. And and another expression I'd like also is that all the infinitive variety of external manifestation of brain activity is finally reduced to only one phenomenon: muscle movements. These expressions show us the important meaning of muscle system. And next slide demonstrate some properties of muscular tissue. That is also 4 properties. First one is electrical excitability. This is a property of both muscles and nerve cells. It is usually the ability to respond to certain stimuli by producing electrical signals called action potentials or impulses. Second property is contractility. It is the ability of muscular tissue to contract forcefully when it is stimulated by another action potential coming to the muscles from outside, from the nerve tissue. The third property is extensibility. Extensibility is the ability of muscular tissue to stretch within limits, and this is a very common function which is done without being damaged. And usually it is possible because of the connective tissue. And fourth property is elasticity. Elasticity is the ability of muscular tissue to return to its original length and shape after contraction or extension. That is a very unique possibility. It is possible because of elastic fibers in our muscles. Next table show us comparative characteristics of smooth and skeletal muscle tissue. And you see that in comparison with skeletal muscles, smooth muscles fiber length is only 50 microns, but skeletal muscles fiber is usually up to 12 centimeters. So it is quite big structure. Fiber thickness is also less in smooth muscles. Only 6 microns for smooth muscles and up to 100 microns for skeletal muscles fibers. Usually every smooth muscles cell has get only one nucleus, but in skeletal muscles fibers there are up to 120 nucleuses for each fibers. As an innervation, autonomous nervous system is responsible for movement smooth muscles tissue, but somatic nervous systems is responsible for moving of skeletal muscles. As I said before, contraction type involuntary for smooth muscles. We could not organize movement food in our digestive tract. It is not possible to regulate, but we easily regulate our skeletal muscles. And localization is also different. In what we can say about all skeletal muscles in our body? I would say there are a lot of muscles in our body, about 640, sometimes 645, sometimes it would be about 630, I don't know. It depends on the development of muscles, but usually only five muscles are unpaired. Other are paired muscles, and you see that mass of skeletal muscles tissue is about 35-40% of total body weight. For male body, for male it is about 40. Men's have more muscles than women's. It is common fact. But as you see, newborn child has get only 20% muscles of total body weights. But when people get old, they lose the muscles. And also it is necessary to say that with intensive physical activity, the weight of muscles would be up to 60%. So it is not bad, but I think when people have about 60% of muscles, they lose it very quickly when they have no intense physical activity more. Okay. What about structure of or some kind of organization of skeletal muscles. Despite their diversity, all muscles have a roughly similar structure plan, and every muscle can have a tendon that is head number 1. It is a tendon. It is a part of muscles which is attached to the bone or to the cartilage. And second, between tendons, usually we could see a belly. It is not the belly in our body, it is a muscle's belly. Don't be confused. And mostly we could find tendon almost in all muscles except facial muscles which help to move our skin. They have only one tendon, not two tendons, attached to the skin. And this is a very important fact, that every muscles has 2 point. Typical skeletal muscles have origin and insertion, and when a skeletal muscles contracts, it moves to these points, origin and insertion, and move bones. Ordinarily, the attachment of a muscle tendon to the stationary bone is called the origin. When one bone with attached muscles has no moving, it is maybe origin point. But the attachment of the muscles other tendon to the movable bones is called the insertion. So it's 2 point, origin and insertion, and sometimes they could change in some special condition. Origin point and insertion point can be changed. Next slide illustrates the way of attachment, the way of combination or attachment muscles to the bones. It would be 2 point. As you see, that is would be attaching to the periosteum. Here is periosteum, and usually tendon connects to periosteum with special elastic fibers, and they help to contract some tendon within the attachment point. And the second is attaching to the cartilage. When there is no bone, usually the tendon is attached to directly to the cartilage, and between collagen fibers is a special cartilage cells which looks like a spring, and they help also to retract and distract of tension. The fact of that the tendon is a very strong structure we can illustrate with two muscles, musculus triceps cruris and musculus quadriceps femoris here. First is it is possible to withstand a force up to 400 kilograms, but quadriceps withstands a force up to 600 kilograms. So that is visible that our tendons are very strong structures. Another this is the scanning electron microscope image, and you can nicely see the strong collagen fibers inside of Achilles tendon. That is in our leg. Our leg usually connect to the calcaneus with such as a strong Achilles tendon, and it is visible collagen fibers inside. What is the inner structure of skeletal muscles? Let's see. Each skeletal muscles is a separated organ composed of tense muscles fasciaces. If we take one muscles and cut it like here, you can see inside of a couple of tense decades of muscles fascicles. This is one is fascicles, and usually the large muscles have more than 20, but regular muscles, especially in our forearm, have no more than 20. When we cut one inside of another fact that there is a connective tissue surround muscles here is visible. We call it epimysium, or sometimes we call it fascia. So what is the fascia? Fascia is a connective tissue surround whole muscles. Usually it carries the blood vessels and nerves. And if we see separated muscles fascicles like here, we can see a connective tissue called perimysium around every fascicle. And inside of fascicle we could find muscle fibers. It is there are some or several muscle fibers inside of each muscle fascicle, like here. And also it is visible that some thin connective tissue surround every fiber and called endomysium. And so we have three types of connective tissue: epimysium around whole muscles, perimysium around muscle fascicles, and endomysium around every muscle fibers. Another picture is also illustrate this. See how this structure look in another picture from Tortora book. This is a cut of musculus biceps brachii or biceps muscles, and you see tendon here. It is a connection with how muscle is attached to the bone, and epimysium or fascia is outside. When we cut biceps, is visible several muscle fibers and fascicles. Fascicles, inside of fascicles are muscle fibers, and every fibers consists of the small myofibrils. Myofibrils is the elements inside of muscle fibers. And muscle fibers, it is some kind of cells, that is cells what were combined together and make, this is a long structure called muscle fibers. And here is also scanned electronic microscopic image of one muscle fibers and myofibrils inside. What is interesting? At high magnification, like here, all muscle fibers appears stuffed with little threads. Here it's visible, threads. These small structures are the contractile elements or skeletal muscles we called myofibrils. So 1, 2, 3, 4, 5 myofibrils, maybe more in each muscle fibers. Myofibrils are components of muscle fibers, and myofibrils, which are about 2 micrometers in diameter, and they extend the entire length of the muscle fiber and have prominent striations that makes the whole muscles fiber look striped. And this is one we called skeletal muscles, like a striped muscles. It is visible. It is a dark and light bands inside of. And why these muscle fibers are striped? It is because of 2 proteins. Within myofibrils are smaller protein structures called filaments or myofilaments. Thin filaments are about 8 nanometers in diameter and usually 1 or 2 micrometers long, and they composed mostly of the proteins actin. We call actin. This is small red filaments called actin filaments, because actin is a protein. But thick filaments, here they are violet or blue. They are 16 nanometers in diameter and also have the same lengths. And those filaments are composed mostly of the protein called myosin. So actin and myosin, this is the two proteins inside of each muscle fibers. And both thin and thick filaments are directly involved in the contractile process. Overall, there are two thin filaments for every thick filament in the region of filament overlap. The filaments inside a myofibril do not extend the entire length of a muscular fibers. Instead, they are arranged in compartments called sarcomeres. This is the basic functional unit of myofibril. Now, plate-shaped regions, here is red and with Z form. This is a dense protein material called Z-disc. Separates one sarcomere from the next. Thus, a sarcomere extended from one Z-disc to another Z-disc. So this is the one sarcomere here. Supporting proteins that hold the thick filaments together at the center of the H zone or H band form the M line. M because it's named because it is at the middle of sarcomere. Here is the center or middle part of sarcomere. So that disc is the border of a sarcomere, but M line is the center of sarcomere. The dark middle part of the sarcomere is A band. Here is a band, which is dark, and this is I band. Here, I band is a lighter, less dense area that contains only thin filaments but no thick filaments, only actin but no myosin. How it works? Usually with the special chemicals we called ATP or adenosine 3-phosphor acid. Usually by contraction each element move inside of other element, like here. This is a relaxed muscles you see here, and elements, all elements are only in the crossover in the small part. And during muscle contraction, thin filaments move toward to the M line of each sarcomere, like here or like here. It is maximally contracted muscles here, and it is also visible in electronic microscopy. Here is non-contracted or relaxed muscles. You see very large large I band, but when muscle is contracted, I band became very narrow, very small one, and during contraction, the myosin filaments and actin filaments combinates, and it is like effect of adding forces when people are pulling a rope like here, and 1 plus 1 plus 1 plus second, and a lot of small forces combined together, and the amount of tension created is proportional to the number of such actin and myosin complex in muscles, like it is proportional to the number of people when they are pulling a rope, like in this picture. Another definition is I'd like to share with you. This is a myon, or motor unit of that is a unit what includes nerves and muscles. What is it? What does it mean, myon, or motor unit of muscles? It is a set. Let me explain in other words. As noted early in our lecture, the neurons can stimulate skeletal muscles fibers to contract, and these neurons or neurocytes called somatic motor neurons. You can see these neurons here, somatic motor neurons, and each neuron has a thread-like axon that extends from the brain or spinal cord to a group of skeletal muscle fibers, and this one called myon. You see that one somatic neuron is attached to several muscle fiber, and it called myo, or motor unit of the muscles. This is a quite new definition, but it is common in morphology, and usually through the nerves impulses come to the muscles fibers, and you get contraction, like here. That is illustrated here. Every muscle fiber contracts in response to one or more action potentials propagating along its sarcolemma and through its system of tubules, like it is visible here. Electrical impulse come here, come to synapse, and inside of synapse special chemicals called acetylcholine get out of synapse and put to the microfibrils here, it stimulate outflow of natrium or sodium elements inside of microfibrils, and gets another electrical potential, and after that muscle fibers contract. We could distinguish two types of skeletal muscles. Depend of numbers of muscles fibers in the one myon, which is in other words, how many muscle fibers is in one myon. It would be dynamic muscles, like muscles of oculus, or special muscles in our orbita. They move our eye and move in different position, and you see only 25 up to 25 muscle fibers is usually for one nerve fiber. And other muscles like musculus triceps cruris or triceps has about up to 230 muscle fibers for one nerve fiber. So here myon consists of more than 200 muscle fibers. In comparison with the eye, we have only 25 up to 25 muscle fibers for one nerve. And it depends the morphological structure of those muscles. We call that red fiber muscles like musculus triceps, and white fibers muscles when we have dynamic static muscles and dynamic muscles. We call also first slow fibers, as they have small diameter, darker color, and fatigue resistance. And fast fibers like muscles of eye muscles, or forearm, some of forearm muscles. They have large diameter, they have paler color, not such a red like in first group, and they usually easily are fatigued. So in other words, these muscles, fast muscles becomes tired very short. After a very short time they become tired. I also like share some clinical and functional significance of skeletal muscles, because you study for a doctor degrees, you should understand what is the meaning, clinical meaning or clinical significance of skeletal muscle. First is they can change our body posture, they can change in gait, they could understand appearance of hypertonicity or a tremor, sometimes paresis, it is visible. They give possibility to see those symptoms. Of course, we could notice the lack of tone or the lack of contractions. In doctors call it paralysis form of diseases. The muscles would displace our bones fragments when bones are damaged, when we have fractures, and they could also make more gap between wound edges, and sometimes the tension of body muscles defends our internal organ, or sometimes we have some symptoms when muscles, especially abdominal muscles, became rigid when some internal organs are inflamed. And of course, it is very important to see reaction of face muscles and understand how patients feel, because like it is a very common expression that face is a mirror of our inner world, and doctors would be very could be very good in observing patients and understand how they feel due muscles contractions. Okay. What about classification? We have a few classification principles of muscles. We could classify muscles by shape, by region, by function, and by origin. By shape, it would be fusiform muscles, biceps or triceps muscles, digastric muscles, broad muscles, especially in abdominal wall. There are a lot of broad muscles. Multibelly, they have few combination, and pinnates muscles, unipinnates, bipinnates, and multipinnates. By shape, we classified long muscles. What is the long muscles? When the length is 2 times more than the width of muscles. For example, we have two caput, or we call these muscles biceps. This one is musculus biceps brachii in Latin, and sometimes that is three caput, or 3 part of three tendons of for one muscles, for one long muscles, and we call such muscles triceps. This one is musculus triceps brachii or musculus triceps surae in Latin. And one of the largest muscles in our body, this is also long one, we call it quadriceps femoris. Here is not normal, but hypertrophied muscles of the thigh. It's located on the anterior surface of our thigh. Sometimes we could find broad muscles in our body. like musculus latissimus dorsi in Latin, or musculus externus, musculus obliquus externus abdominis, or musculus transversus abdominis. A lot of broad muscles are located in our abdominal part or of the body, or on our back. And when we talk about broad muscles, we mean that their tendons are called aponeurosis. Aponeurosis is a tendon of broad muscles. And short muscles as well. What is short? What does it mean? Short muscles. Short, we mean when the length of muscles is 2 times less than the width. Such muscles are located in the neck, in the back, and they are very, very short. It is really visible. And as I said before, pinnate muscles, unipinnate, bipinnate, and multipinnate, they have the structure like a feather, like a bird feather, and such as a long tendon and short muscle fibers. They are under the angle, with the angle connect with the tendon for construct an angle between them. And different form, we could find square muscles. Here is musculus quadratus, musculus pronator quadratus in forearm. Triangular muscles is musculus depressor anguli oris here. And serrated muscles, this is in the lateral wall of the chest. Deltoid shape and circular shape. Here, musculus orbicularis oculi and musculus orbicularis oculis. You see, that is a circular shape. Sometimes we could find a couple of or 3 or 4 more myotomes that make muscles connected with the tendon, like here, one of the famous neck muscles or abdomen muscles. It is a connection we call in Latin interconnection tendinous on the surface of muscles. It means that the muscles was developed from 1, 2, 3, 4, 5 myotomes. 5 myotomes combined together and make one muscles. And another classification is the functional one. When we divide muscles by their function, they could make flexion, and that we call flexors, or in antonym is extensors. Abductors and adductors, rotators, sphincter and dilatators. Maybe you remember such muscles. When we because we studied the type of movements, and the same name come from the name of the movements. A couple of words about muscles work. The strength of muscles or muscles force is depend on several characteristics. They are determined by physiological muscle diameter, as well as the size of the area of support on bones, and maybe supports of cartilage or fascia. the manner of force is exerted, what kind of lever act on the bones. The degree of nervous excitement, you see that the more electrical signals come to muscles, the more force we will have. And of course, adequate blood supplies influence of the muscle force as well. What is the anatomical section? What is the physiological section? Anatomic section is just as a cut of this. This is the section and the square. Square of the section in perpendicular section is called anatomical section. But for muscle works, it's better to understand what physiological section means. That is a plane passing through all fibers. Here is the physiological section is with a stripped line, and anatomical section is whole life. But when we have such muscles like oblique muscles, when we have muscles unipinnate or bipinnate muscles, the physiological section is not the same as anatomical. So, and for the force, more important to understand a physiological section. We can also divide muscles for synergist and antagonist. Maybe you understand. Synergist muscles are muscles what do the same movement. They are synergism. They make synergism in our body. But antagonists are muscles what involved in different or oppositely directed movements, like biceps and triceps. Biceps is antagonist to the triceps muscles in our arm. And this is a characteristic what can help you to understand the level structure and types of lever in the body, and it influences of the movement or some kind of movement. Here is the musculus biceps brachii or biceps brachii muscle, very famous muscle, and you see that there's a point of here 2 points. This effort is here, effort, point of effort, and of these 3 points, levers. And first one is the fulcrum, when the fulcrum is between the effort here, and here is the fulcrum, here is effort, and here is load, and it is like how it called, it is like seesaws, or like on this picture this is a scissors type of levers. And second class levers, when the load is between the fulcrum and the effort in second class one. This is a central figure. Here is visible that the fulcrum is here, but effort is on the longer shoulder, then load point. And the third class levers it is when the effort is between the fulcrum and the load, like here. Usually these levers operate like a pair of forceps, and they are the most common levers in the body. Third class levers always produce mechanical disadvantages because the effort is always closer to the fulcrum than the load. In the body, this arrangement favors speed and range of motion over the force. Excuse me. Алло. Я слушаю вас. Извините, у меня лекция сейчас. Вы зачем звоните мне на мой номер, на мобильный? Вам кто давал мой номер? Не надо мне звонить, пожалуйста. And I'm sorry. There are three types. Depending on the levers, we could find the three types of muscle activity in our body. First picture illustrates static work, when the muscles support various posture and body position. The third is overcoming work, when the muscles overcome the weight of a body part or an external forces. It is a common types of muscle activity. And the third one is yielding work, when a muscle is stretched, is being stretched by external forces. And I also share you muscle assistance. It would be fascia, or you remember that is epimysium. It is a connective tissue surround the muscles. Superficial, it would be superficial, intrinsic, or internal fascia. It's very popular because fascia is a good helper for muscles. They protective muscles against overrestriction, and they save the strength of the contracting muscles. Sometimes they stretch veins by participating in blood circulation. Of course, one of the idea why fascia is when fascia cover muscles is because they eliminate the friction when muscles in the moving process. And of course, surgeons think about fascia sheets, about fascia when they have operation, because especially when patients have infections and tumors, because fascias limit the spread of those diseases. And of course, for surgeons, fascia helps to understand landmarks during operations. The second additional assistant of muscles are fibrosis and osteofibrosis channels. That is the space between fibrosis membranes, what is consist of some synovial membranes and some tendon inside, and we call those cover like a fibrosis or osteofibrosis channel. And synovial sheath, I told you when we have arthrosyndesmology lections, and this is a special combination of synovial sneeze and tendo what reduce friction. I told you, informed you about synovial bursa as well, and sesamoid bones, they also help muscles to walk. The development of muscles come from the somites. This is a small part of embryo body, and this is a somites is a part of mesoderm. All muscles are derived from mesoderm. That is a middle sheet of embryon. Middle layers. It would be better to say layers than sheet. And this is a red objects, and red objects are all of those is mesoderm, and you see that there is a three-part: dermatome, myotome, and sclerotome. Myotome, and dermatome. Myotome is origin of muscles. It go up and down, forward and back, and you see it is a source of all muscles in our body. So when somebody asks you about development muscle, just answer it is come from myotomes, different myotomes. And here you can see different myotomes of the head and trunk of the human embryo. And the last part of our lecture, we have not enough time for that, but I'd like to give you this part for the your personal education, and we could talk about head muscles. This is a two group of head muscles. First group we call facial muscles. That is mimic muscles with what help our skin on our face to move. You see that all facial muscles located around natural or around some natural hole like orbita here, or cavitas oris. It is circular muscles what do as a sphincters. And another muscles on our face works as a dilatators. They open our mouth or open our eyes. Some muscles are around of ears or around nose, and quite large muscles is on the surface of cranium cerebrale. This is occipitofrontal muscles here. It's also visible another view to see ear muscles. They are reduced in our body. We don't need to move with our ears because we use our neck to listen to the directly to the source of voice. And the second group of head muscles is masticatory muscles. There are only 4 muscles in our head. 2 of them are located on the lateral part of our skull. This is the masseter muscles and temporalis muscles, musculus temporalis and musculus masseter. And another 2, we called it pterygoid muscles, are inside, is under the mandibula. We just in order we'd like to see them, we could cut mandibula and see 2 pterygoid muscles. And another regio we could to study, this is the neck muscles. We have 3 groups of neck muscles. This is the superficial neck muscles like musculus sternocleidomastoidus and musculus platysma, another name of. They are located very close to the skin. And second group is middle group. We called suprahyoid and infrahyoid muscles. They are attached to the hyoid bone. Here is a hyoid bone, and infrahyoid muscles and suprahyoid muscles. And it is also visible on the front view. And the third group is the deep muscles of the neck, medial subgroup and lateral subgroup, also called scalenic muscles. Only 3 muscles: anterior scalenic, middle scalenic, and posterior scalenic muscle. That's all for now, my friend. And you have a task. To study head and neck muscles yourself, and I ask your teachers to explain the origin and insertion of this muscle, as well as the function in your next classes. This is all for now. We'll see you next Monday, and I wish you everything what you can wish for yourself. Thank you very much. Today we have no task in the Moodle, because Moodle works not very good, so I hope we will have task next time. If you have question, please put it in our chat. If there is no question, so let's say you goodbye.